Hi, my name is Steve. I used to be a software engineer at Google. Now I'm back in what we call professional services. We've got, who's here from professional services at Google? There's one, at least. And you know him, right? Cool. So I'm here to talk about some work that's been going on that Ken and Radek's not here. He's out enjoying the sun somewhere else, I think. Radek, enjoy. Thanks for putting me up here. It's about how you can integrate Beam and Dataflow, well, Dataflow in specific is that we work on, with your distributed tracing system, or actually, we'll keep it limited. We're only going to focus on OpenTelemetry today, but maybe in the future, something else. And it was a fun use case for another feature that's being worked on that we'll briefly touch on, but not too much because it's an implementation detail. Anyhow, the current state of trace propagation in Beam runners is something that we're going to touch on, the implementation status of the OpenTelemetry work that we've been doing. We'll just have a look at that. And fingers crossed. No, I actually checked it. We'll do a little live demo of this as well, and I have backups of some other thing I ran a while back. So, what is the state of trace propagation in Beam runners today? Well, today, and this is something that people complain about, you might pick up a message from some service, or a service publishes a message to a queue, say, pops up. And then in Dataflow, pipeline picks it up, and that context is dropped. And you as a pipeline author, or the owner of any of the orange boxes, you might not care, but your teammates on the other end, the yellow boxes, they will care. That last service at the very tail, that's not your problem, but they would likely want to propagate something. Well, what is that something, and why should I care? So when you're analyzing performance in one of your pipelines or in a whole hierarchy of applications, in some constellation of, say, web services and databases and queues and stuff like that, you might want to figure out something that you can gain from your profiler. So your profiler gives you good information about what goes on in a program and in aggregate, right? All the paths that have been taken by the program, how much runtime was spent there, how much memory was consumed there. On the wall, if we take into consideration I/O waits, right? How long have we been doing idle work, right? Tells you that. What it doesn't tell you is for a single request, what did that look like? Give me the slice of single request. What path did it take? What path did it not take? Why was it so slow in the first place? You get to this, like the nuance is what you get when you have traces and a nice tool or tooling of applications that visualizes that for you and makes it analyzable and digestible by us, right? It doesn't only do that, it also allows you to do this for all the other services that may have touched that particular bit of information. So if you as a user create a new profile somewhere, or if you place an order and you go through payment, all of that stuff, you can add the what we call a span, so a portion of time in which that particular element passed through a function or some other part of a program that we are interested in. We can take that and correlate it to all the other portions of time of all the other developers that work on this big constellation of services within an organization. And we can figure out from, the very beginning, the birth of that context, of that interesting bit of information, all the way to, well, where we don't care about anymore. The order has been fulfilled or payment has been completed. What happened? Was it slow? Was it fast? What path did it take? Did it take any feature-gated code paths? Is that why something was off about how this order was handled? Not something that you might want to track. And even in your data pipelines, that's something you might want to propagate, if not for your own sake, then maybe for the sake of your colleagues, right? So where we want to get to is this point where automatically, not even just Cloud Dataflow, but all of the Beam runners that we have. Cloud Dataflow is just our interesting case for this. They all propagate that context seamlessly. That's the preferred way we would want to do this. And you, as an author of a pipeline, get more control over how you add spans to this ongoing trace of a particular element, right? Or the attributes that you attach to it. It passed through this particular function, or this shard, or this, however you want to slice and dice it, right? It's up to you. And we're here to make sure that you get all of the tooling that you need to get to that point, preferably without hassle, without boilerplate, and also without changing too much about the existing interfaces and stuff that we already have in Beam. So for transforms, the main thing you want to get out of this, if you're writing I/O, you want to extract a context on input and propagate a context on output. Now that we're going to, well, hopefully we can make that seamless, but largely that's going to be up to you. How you extract a context from a bit of source information, or how you propagate a context to a storage system or a queue, it's going to be something that is very much custom to how you run your application, how you run those constellations of services, right? The thing that is fairly boilerplate and standard is creating new spans, adding attributes, modifying the span context and the trace context as it's flowing through your Beam pipeline, your data pipeline. For the runner, the main concerns here are, well, we need to provide a tracer provider, just like we already provide a container for metrics, right? We need to configure that instrumentation. We need to send stuff off to what we call, for OpenTelemetry, we call an exporter. So it's just some other destination that picks that up and stores it somewhere, or processes the traces, or processes spans into traces, so you can actually visualize and analyze them. And for us, the most important thing, the most fun thing to work on is how do we propagate those spans, or how do we propagate those trace contexts across stages, right? So we have I/O in Beam in our data pipelines as well. It's a shuffle, right? We pass through a shuffle, and either that happens locally if you're running on, say, a direct runner where you're not doing interesting stuff, or you've got like a half fusion break, as we just heard, right? Or you pass it off to a totally remote machine. And if you're doing an aggregation, you might actually compact a bunch of elements and their contexts into one new context that you want to then follow along all the way to its destination. So that's the fun part. But a prerequisite for that is that we need additional metadata in what we call windowed value. So the lowest level element that can pass through a pipeline before we hand it off to the network and turn it into bytes. So there's been a fun challenge in fitting a couple bits here and there in empty spaces in the encoding of that windowed value to allow us to extend it, and hopefully extend it indefinitely into the future. So we can add additional contexts and metadata to a windowed value that we may not have thought about, years ago when all of this was created in the first place. So that's a fun thing. Talk to Ken if you want to hear more. Him and Radek have been really busy figuring out where to put the bits and how to get it all to wire up and work and not break anyone in the process, hopefully. Cool, you didn't come for that, but this next part and then the demonstration is going to be fun. How do we do this for portability? So the big runner that you would use if you want to integrate a new system today, right? We want to make sure that you have all of this just out there on day one, not just in Dataflow. We want you to have a good experience wherever you are, if you're on Flink or on Dataflow or Spark or whatever it might be. So for portability, the thing that we've come up with is we'll add a Java agent to the SDK container edge. We'll, for the sake of this experimental phase, we'll just configure the -Java agent line, and that's it. If you want to customize it any further, specify what address the exporter runs at, just go and build a custom container. We'll figure out how to sort of wire that up eventually at some point in the future. So your agent loads extensions, so framework instrumentation, bundles of code that will latch onto existing libraries, like Kafka, for example, so the Kafka client library, and hook into specific places to create spans, authentication providers, you name it, a bunch of stuff. The agent also turns instrumentation annotations into generated bytecode. So all of the stupid boilerplate stuff that you need to do to actually get a span is taken care of. And you just do @ span as an annotation on whatever method you want, and you're done. And you can have fun. The global environment is initialized, so you can get an instance of this global OpenTelemetry thing that you need. This is roughly the way that, as a framework author, a place where user code runs at some point, you want to be able to provide a handle to that to your users and have them create spans and all sorts of contexts that they might need for the span and trace creation within their pipeline. And the agent also acts as the exporter for the JVM, so that runs completely separate from your pipeline. If that crashes, the agent doesn't necessarily crash immediately as well. But that's about it. So overview, as you can see, it's quite simple. The injection hooks into your do funds or whatever other place you might put OpenTelemetry stuff in your pipeline when you're building it, or when you're building transforms in I/O. So if you have framework instrumentation, it will latch onto that. So there's instrumentation for gRPC, for Kafka, for a bunch of other stuff. There's bytecode generation, as I said, for these annotations. And then we can also inject these tracers and meters for manual instrumentation that you might want to write yourself. You don't want to use all the auto magic stuff, but you know what you're doing. You know that you can do it any other way. We're also going to give you that. Cool. So without further ado, let's have a look at what that looks like, right? So I've got a laptop over here. Let's hope that we can switch that over. There we go. Awesome. All right. So Radek prepared this tiny demonstration. We're going to first go over, well, we don't even really need to go over the pipeline definition itself. It's just accept any input, do something somewhat interesting looking to it, do counts, do logs, and that's about it. And then at the very end, we're going to write out to Kafka with tracing, so you can actually propagate it on. And at the source, we're going to read from pubsub with OpenTelemetry tracing enabled as well. This is all experimental setup. We're not sure if this is going to be the final way that you configure this. Hello, we're not going to invalidate my credentials right now. Or shut down my workstation. That's not great. Cool. So what does that look like if you want to build a span? We've got a couple of instances of that right over here. So we have spans right down here on process element and on timer. The spans are named on timer, and this one's called stateful. How creative, right? We can add events to the spans, so that's just additional information that we pass on. And then finally, once this is done, we can call end on the span, and then it's all gone. We finalize it, it ships off. Eventually, what you want to do is make sure that this just disappears into the background, right? That if you don't care about all this stuff, you don't have to. You just annotate it like you annotate your method with @processElement. You do @with span, which is already provided by the OpenTelemetry API, the SDK, sorry, the instrumentation SDK. And then you're off to the races, right? You get a span, you can do whatever you want to it, and at the end of your process element, you don't care. You just say, all right, I'm done. We finalize the span for you, and it's done, right? So Radek also has this fun little pipeline running for a good 76 days already. Wow. And it's hooked up to this pubsub topic over here. And let me see, I'm going to refresh this real quick because I think I ran that. Yeah, there we go. We're going to go and do 100 hello worlds. Hello world. I know there's a comma in there somewhere. Publish, and that's going to go off and send 100 hello worlds through this pipeline, which unsurprisingly gets picked up. We should be able to see that in a bit at the front over here, but in the tracing UI that we have in Google Cloud Platform, we already should have a couple of spans popping up over here. This is set to auto refresh, so we're getting a bunch of these in. The shade on these colored bars tells you how many spans are in a particular bucket. So y-axis is time from longest to shortest. So here at the bottom, we've got 9 spans that ran between 0 and 100 microseconds. And then at the top, we've got a couple that are not slow, but like they could do better. There's 8 of them that ran in 1 second. Half a second to a second-ish, right? And we can see these ones come from PubSub, and then we can go and inspect them. So we've got 4 spans that were collected that we can analyze here. We can see those pop up here, including all the attributes that are associated with them. If you've got logs and events, so metrics, if you use the OpenTelemetry metrics API and the logs API, you can correlate them here as well, which would be really, really neat. Stack traces, same thing. And then there's some metadata and links here, which is just, we got a project ID, that type of stuff. But attributes is going to be the thing that you're going to care the most about, because that's where you stuff all the interesting bits about, well, this is what this element meant to me, right? And then one tiny, we're not going to show off, but just to show that it works at scale, I've got one pipeline that runs Kafka.io at 10 gigabytes per second. And here we have one slice of time where we collected almost 200 million, 180 million spans between 0 and 100 microseconds. So that was fun. So that's what you get. I mean, if you have any other tooling yourself, then it's not going to look the same as this, but you're going to get the same information because it's all just OpenTelemetry data that we're sending you. So even if you're not using cloud tracing, you are still going to get the same trace data right out of there. The way you would configure that, because I said for run every 2 or for portability, right, for the SDK container image, the only thing we've added, and this is all, we haven't even added it, it's in a PR somewhere, so it's not committed. The only thing we would add, or that I would propose to add, is that we have a new experiment and that we add this one line all the way at the top, right? And all this other stuff that comes after that, we just leave up to you for now, and we'll figure out a way to sort of nicely bundle this up and make that accessible through, say, pipeline options or something like that at a later stage. But that's about it on tracing. Thank you very much.